the session, right. So, in today's session we will discuss about the basics of Nyquist plot. So, in the last session we discussed about the polar plot and we discussed the stability from polar plot and we discussed about the concept of enclosement. Okay. So, today's session we will discuss enclosement and encirclement concept. We will see the principle of argument, we will see the Nyquist stability criteria and then we will see what are the conditions for stability. Okay. So, for concept of enclosement and encirclement, we have to take the same example that I had taken in the last session. Suppose this is the curve, if my point B lying on the right side of this curve, then we can say this is enclosed, where point A is not enclosed by the curve. So, this is the principle of enclosement. In the same way, principle of encirclement, if I make a closed curve or contour around point A, so we can say point A is encircled by this curve and point B is not encircled by this curve. Okay. So, this statement we have to use here. So, we would like to see here the concept of mapping. Okay. So, in the mapping what we are doing to do, we are mapping our S plane into GS plane, where I am assuming my GS plane is here 1 over S plus 2. So, first I would like to plot my this open loop transfer function GS 1 over S plus 2 in the plane. So, here I am making this pole at S equal to minus 2 and then I am covering it with a curve, closed curve around it, and here I am moving in clockwise direction. So, for mapping I will take certain point on this plane, that is point A is here, point B is here, point C is here, point D. I am making the imaginary part is here plus j and this negative axis would be around minus j and this intersection point would be, you can say, or around minus 1 and this point is around minus 3. So, this will become here you can say minus 1 plus j, then minus 1 minus j, then this will be minus 3 minus j and this will be minus 3 plus j. Okay. So, if I plot all this point here, so we will get the different phase here. Okay. For all the case, my mod would be 1 by root 2 and my phase would be plus 135, 45, minus 45, minus 135. So, how I am calculating it? I have to put, suppose I have to put a point A minus 1 plus j in this plane, I will replace S by minus 1 plus j, I will get this transfer function and this is the magnitude and this is the phase. In the same way, if I have to plot minus 3 plus j in GS plane, I will replace S by minus 3 plus j plus 2, this will gives me this much transfer function, magnitude is this much and phase is this much. So, in this way I will plot all this point, okay, and then I have to map the GS-HS plane. Okay. So, in point A you can say it is going around, you can say 1 by root 2 the magnitude, my phase is minus 45. So, here this would be minus 45 phase go here, then same magnitude is here, you can say it will go for plus 45, then for minus 135 will be this curve, okay, and plus 135 would be this curve. Okay. So, what you will obtain that my this contour is enclosing the origin in anti-clockwise direction. Okay. So, if I plot this point again, you can say we are moving here A, B, C, D in clockwise and here we are moving A, you can say you can say here first A is here and then D we are moving, then we are moving towards C, then B. It means we are moving in anti-clockwise. So, one concept that we are getting here, if one pole is enclosed or encircled by a closed loop in clockwise direction, then in GS plane same pole will lie, you can say it will lie at the origin and it will enclose by curve in anti-clockwise direction. It means this contour will encircle the origin in anti-clockwise. Okay. In the same way, when we do this principle or do this concept for 0 GS equal to S plus 2, then what we will obtain? If we are making contour in clockwise, so in the GS plane this contour will remain in the clockwise and it will encircle the origin once. Okay. For pole what it is coming? It is encircle the origin in anti-clockwise, but for 0 it will encircle the origin in clockwise. You can do this calculation from your side to verify it. Now, we would like to see the principle of argument. Okay. So, what it tells, if p number of open loop pole encircled by a contour in clockwise direction in S plane, then in corresponding GS HS plane it will encircle p times in opposite direction. Okay. It means, if in S plane movement is clockwise, in GS plane movement would be anti-clockwise whenever it is pole. Second concept, if Z number of 0 lying, you can see in the open loop, suppose Z number of zeros lying in the S plane, if you encircle the 0 in clockwise direction, then in the GS HS plane they will encircled by clockwise direction, or you can say they will encircled in same direction. Okay. So, here you can see, if p number of open loop poles and Z number of, you can say, open loop 0 are encircled by contour in S plane, then in corresponding GS HS plane origin will be encircled by n times. So, this is the one formula, n equal to p minus z, where n will tells you number of encirclement around GS HS plane and number of open loop poles encircled by contour in S plane. Z will tells you number of open loop 0 encircled by contour in S plane. Okay. So, why p minus z? Because of pole I was getting anti-clockwise movement, and because of 0 I was getting clockwise movement, right. So, that is why it is subtracting here p minus z. So, this is the principle of argument that we have to use for Nyquist criteria. So, to clarify it, we can take this example. So, here this is the closed contour in the S plane. Now, it is enclosing 2 poles and 1 0. Okay. So, here my one pole is enclosing by it means this will gives me anti-clockwise rotation, right. It means, if I plot here in the S plane, this will gives me one anti-clockwise rotation and it will enclose the origin. Second pole is here, it means again I will get one more enclosement around origin, but in which direction? Anti-clockwise, because this contour is here clockwise. Now, 1 0 is coming here, it means what will happen, this enclosement around origin will takes place in the same direction, but or you can say in clockwise direction. So, if I sum up this result, 2 anti-clockwise plus 1 clockwise enclosed encirclement will gives you 1 anti-clockwise encirclement. So, that is why in the GS HS plane my origin will encircled anti-clockwise only one time, right. So, this is the principle of argument. On the basis of same, how to calculate the phase covered in the encirclement. So, I am assuming certain zeros are here, alpha 1, alpha 2, beta 1, beta 2. Alpha 2 is 0, beta 2 and beta 1 are the pole. So, basically what is happening here, 1 plus GS HS is given, this pole is 0 is S minus alpha 1, this is my 1 0, second 0 is S plus alpha 2, divide by, you can say, one pole is my S minus, this pole is S minus beta 1 and this pole is S plus beta 2, right. So, I had plotted this. Now, I encircle this 0 in clockwise direction. Okay. So, I would like to know what is my phase contribution by this alpha 1 if I am moving across this contour. If I am moving in this closed curve like clockwise direction, I will calculate its phase with respect to alpha 1. I will calculate its phase here, its phase here, at phase at this point, phase at this point, phase at this point, till I had completed my one closed circle. Okay. After moving the whole contour, I will find the angle contribution by S minus alpha 1 is minus 2 pi, because we move in clockwise direction 2 pi times with minus sign, because we are moving in clockwise. Now, in the same way, I would like to observe, if I am moving in this contour, what would be the angle contribution by alpha 2. So, here this angle contribution is some value, then some value would be here, then some value would be here, some value would be here. When I return back to the same point, the total angle contribution would be 0, because whenever it is going in positive direction I will get the positive angle, whenever it is going in negative direction I will get the negative angle and they will cancel out. So, angle contribution by S plus alpha 2 would be 0. In the same way, when we go for the pole, okay, sorry, if you can say beta 2 and beta 1, their angle contribution would be 0. So, here if my contour enclosing this 0 alpha 1, so I will get the phase coverage of around minus 2 pi. In the same way, if this contour is enclosing any pole, then what will happen? We are moving clockwise, again we are getting here phase shift of minus 2 pi or angle contribution of minus 2 pi, but this is pole and this pole is lying in the denominator. So, instead of minus 2 pi we will get here plus 2 pi angle contribution. Okay. So, always remember, whenever we are moving clockwise around 0, total contribution is minus 2 pi, when we move anti-clockwise around 0, total contribution is plus 2 pi. So, this is concept of or phase cover of encirclement. Okay. On the basis of that, we would like to solve one problem. So, a pole 0 map is given of GS plane, okay. Basically HS is unity, that is GS HS plane, where a closed contour gamma is given. This is the closed contour gamma is given here, which is mapped into GS plane. The mapping encircles this type of you can say poles and 0, right. So, what would be my option? You can say the origin of GS plane once in counterclockwise direction, it will happen. The origin of GS plane once in clockwise, or the point minus 1 of GS plane in counterclock, or minus 1 point in GS plane in clockwise, which would be correct. So, we can see here this 0 will gives you minus 2 pi angle contribution, this 0 will gives you minus 2 pi, this 0 will gives you minus 2 pi, and this pole will gives you plus 2 pi angle contribution, this pole will gives you plus 2 pi, and this pole will gives you 0 angle contribution, this is 0, this is 0, okay, and this will gives you 0 angle contribution. So, how much total phase is coming? This minus 2 pi plus 2 pi cancel out, minus 2 pi plus 2 pi cancel out, I am getting here minus 2 pi. It means in GS HS plane encirclement will be around origin, minus sign is here, it means in clockwise direction only one time. So, you can say the origin of GS plane once in option B is here, the origin of GS plane once in clockwise direction. This is my correct answer. Okay. Now, we would like to see the Nyquist stability criteria. Okay. So, to determine this stability, we have to observe what is my any open loop pole or closed loop pole lying in the right half plane. If my closed loop pole lying in the right half plane, it means my system is unstable. Okay. So, what I will do? I will just plot my S plane and then I would like to scan my whole right half plane to the value of infinity. Okay. If there is any closed loop pole lying somewhere else, so this will tell us my system is unstable. Okay. So, here what I will do? I will scan whole the right half plane, and if there is any pole, so I will get this encirclement around origin. If 2 pole, so I will get encirclement 2 times around the origin. So, this encirclement will tell us around origin how many poles lying in the right half, and this will make our system unstable. Okay. So, this is the Nyquist stability criteria, right. So, here this enclosement we have to observe in the complete right half plane for infinite values, so that we can scan all the right half closed loop poles. Okay. So, here we are moving this closed loop in the right half plane by a varying frequency omega from minus infinite to plus infinite, okay, and stability determined with respect to critical point minus 1 plus j 0. Okay. So, why we are choosing it minus 1 plus j 0? Because we know that quadratic equation is given by 1 plus GSHS equal to 0. So, to determine stability, I will equate it to minus 1, and minus 1 will act as here a critical point. Okay. So, this will tell us whether my system is stable or not, right. So, here I need to check encirclement of minus 1. Okay. So, one more concept we need to see, 1 plus GSHS is equal to 0, this will give us the roots of equation used in closed loop pole. Okay. And open loop transfer function GSHS given by k times ns over ds. K is the gain, ns is the numerator and d is the denominator. This will gives me zeros of open loop transfer function and ds will gives me poles of open loop transfer function. So, whenever I am writing 1 plus GSHS, so generally this 1 plus GSHS term come in denominator. Okay. So, here if I write 1 plus GSHS, it is 1 plus k times of ns over ds equal to 0. If you solve it, this will gives you ds plus k ns over ds, right. So, what I am getting, this 1 plus GSHS will gives you certain transfer function. Okay. So, this numerator part will gives you 0, right, but in actually if I find out this is my open loop transfer function, if I have to convert it into the closed loop transfer function. So, this function would be given like this. I told you this concept how to obtain closed loop transfer function from a given open loop transfer function. So, here what is denominator? This is ds plus k times of ns, which is giving us closed loop pole. Okay. So, here I can say ds plus k ns what? This is the closed loop pole, but if I observe it with respect to the quadratic equation. So, this is giving me zeros of quadratic equation. In the same way, what is ds? ds is the open loop pole. Okay. So, what is the meaning here with respect to quadratic equation? The poles of quadratic equation is giving us the open loop poles. Okay. So, if we summarize, the closed loop pole will be, you can say, zeros of quadratic equation and open loop poles would be what? Poles of quadratic equation. So, this concept is very important to determine the stability criteria. Okay. So, in Nyquist criteria we observe the encirclement of the closed loop poles and zeros in right half of the S plane. So, we have to see how many poles and 0 lying in the right half with the help of concept of encirclement, right. So, here we are doing this for 1 plus GSHS plane and we were observing the encirclement of origin. So, here to simplify it, what I am doing, I am converting it to the GSHS plane, right, because in the previous session we were doing this thing in the polar plot, we were converting or we were mapping S plane into GSHS. So, that is why I will convert this 1 plus GSHS plane into GSHS by shifting this plot around -1. So, here we were encircling the origin, here we are doing this for -1 and this is the critical point that will tell us why our system is stable or not. Okay. So, remaining concept we will discuss in the next session.